Good morning. Okay, now I'm going to show you this video that describes from global to local alignment. My apologies. So, first of all, we are going to check which limit has this alignment system. We identify matches. We grant a match with midpoint, a mismatch with sigma, and index with a different amount of value. This is an example. A match was rewarded by 2. A match was rewarded by 1, my apology. A mismatch by -2. And an indel by -2. My apology. A match by 1, an indel by -2, and a mismatch by -3. This is our scoring method at the moment. So I have the scoring matrix here. This is our scoring matrix. And the more general one is this one, where I have mi sigma. This is how to score matrix, a scoring matrix for amino acid sequence, for example. And we know that Y mutating into F more frequently than into P. Now we continue to investigate the dynamic programming recurrence. For each point, for each node, I'm going to select its predecessor using the value of the node plus an arc. So in this case, I have in this generic matrix, for each node, the maximum between 4 values. The value Sij minus 1 minus sigma, or Sij minus 1 minus sigma, that's a different node. Sij minus 1, Sij minus 1, I minus 1 plus 1, if the values are identical, or Sij minus 1, I minus 1, minus me, if the values are different. So I'm going to select the maximum between these 4 values. Why do I have 4 values and 3 arcs here? Because this is one arc, the horizontal one, the vertical one is a different arc. And this arc could be or 1 or minus me, if the 2 values are a match or a mismatch. And now I'm going forward, okay? We just go through this one. We backtrack, okay? What is the problem? In this alignment, I have 2 alignments. In the first one, I have 22 matches and 20 indels, and the score is 2. While in the second one, I have 70 matches minus 30 indels, and the score is minus 30. But when I investigate them visually, clearly the second one appears to be much better than the first one. And this is a local alignment, and I should identify a scoring system or an algorithm to identify local alignment. As you can see, this is the best global alignment on the matrix. This is the alignment matrix. And this is the best local alignment. It's much more better. And the problem is, how do I identify this path? This is a local alignment, and this is a global alignment again. So I'm going to compute a global alignment within each rectangle to get a local alignment. How do I do it in a computationally efficient way? We are going to outline the local alignment problem, how to find the highest scoring local alignment between two strings. We have two strings, V and W, and a matrix score. And as output, we will have a substring of V and W whose global alignment is maximum along all global alignments of all substrings of V and W. So I'm seeking for a substring. How do I do it? Using free taxi rise. What does it mean, free taxi rise? It means that I'm considering not to get any weight up to the beginning of the string. And what do free taxi rise mean in the term of the alignment graph? I'm going to connect each node to all its successors, but with a traveling cost of 0. But the problem computationally is that I add a really consistent number of edges, and I do not like it. I prefer to have more nodes than more edges. So, what we can do is to consider 0 as a cost of going from a point A to a point B. And we are going to see how to do it in the next class. Okay. Detenere grabazione.